So next topic is projectile motion. So suppose if you are standing on, say, a ground, okay, and say you throw a ball at a certain angle with the ground, say like this. This velocity is u and it is thrown, the ball is thrown at an angle theta with respect to the horizon. What will be the trajectory of the ball? It will go like this and then it will strike the ground at some distance. Now this is a case which is very often sort of a subject of many problems and many numericals. Now what we need to understand here is, see, this velocity u, it's got two components. One is along the horizontal direction, which is a u cos theta, and the other component is along the vertical direction, that's u sin theta. And on this ball, throughout this journey, there is one constant acceleration acting, and that is downward g, acceleration due to gravity. G is equal to, we all know, 9.8 meters per second square. Now there are a couple of parameters that we should know here. First parameter is the range. Second parameter is the height, that this ball travels, maximum height up to which this ball goes before it starts coming down, and the time taken for the ball to reach from here to here. So all these are you can calculate all these parameters or quantities in a very straightforward way. So what we need to understand here is that this component u cos theta will remain constant, because this is the component of the velocity in the horizontal direction, and there is no acceleration acting on this ball in the horizontal direction. There is only one acceleration acting on this ball, and that is g, which is acting in the vertical direction. So which means that in the horizontal direction the velocity will always remain u cos theta. Let us talk about the vertical direction. Say if we consider the motion of the ball from here to here, the total displacement in the vertical direction is 0. Why? Because it started off from this point and it ended up at this point. So in the vertical direction, the total displacement of the ball is 0. And the initial velocity of the ball in the vertical direction is u sin theta. Right? So let's apply this equation. S is equal to ut plus half at square. Ut plus half at square. If you apply this equation, what do we get? 0 is equal to u sin theta t plus half minus g t square. Right? U sin theta is in the upward direction, so I am taking the upward direction as positive, and any quantity which is acting in the downward direction, I am taking that to be negative. So g is negative. If you solve this equation, what do you get? T is equal to 2u sin theta by g. Right? This is the total time of flight. And since the ball leaves from this point and it hits this point, how much time does it take from here to here? This much time. Similarly, you can calculate what is the total distance that it goes up. V square minus u square is equal to 2as. V will be equal to 0. U will be equal to u sin theta. 2 minus g s. So s will be equal to u sin square theta by 2g. What is the total range? This distance, u cos theta multiplied by this time, u cos theta multiplied by 2u sin theta by g. So let's take a question. Two bodies are thrown up simultaneously from a point, one straight up and the other at an angle 60 degrees to the horizontal. The initial velocity of each body is equal to v naught equal to 25 meters per second. Neglecting air drag, find the distance between the particles 1.7 seconds later. Okay, so it's a case where, say suppose if this is the ground, so there is a particle, there are two particles, one which is thrown vertically upwards and the other which is thrown at an angle equal to 60 degrees with the horizontal. Both the speeds of both the particles are equal to 25 meters per second. What is the distance between the particles 1.7 seconds later? So the approach is, just find out the x and y coordinates of both the particles 1.7 seconds later, and then find out the distance between the two particles based on their respective x and y coordinates. Now, while we are doing that, we are considering this to be the origin. So this point is the point where x is equal to 0 and y is also equal to 0. Okay, so we will be calculating x and the y coordinates with respect to this point. Now, say the particle 1, it has been thrown vertically upwards with a certain velocity. If we calculate the s for this particle or the displacement for this particle, this will be equal to ut plus half at square. Square. Why? What is 25? The initial velocity t is equal to 1.7, which is the time interval, plus 1 half g. This is minus 9.8. I've taken a minus sign because it's acting downwards and the particle is being thrown upwards. And 1.7 square is t square. So we are calculating the displacement in the y direction for the particle 1 or for body 1. I have to calculate this. This will be equal to 28.339. This is the vertical displacement for the particle 1. For particle 2, there will be two displacements. Why? Because it is thrown at an angle, so there will be a horizontal displacement and a vertical displacement. Its velocity has a horizontal component and a vertical component, both. So as we know, the horizontal component will remain constant because in the horizontal direction there is no acceleration. The only acceleration that exists is in the vertical direction. So the vertical component of the velocity will have a certain initial value, but that will change with time. But the horizontal component of the velocity for this particle 2 will not change with time because there is no acceleration in the horizontal direction. So for particle 2, if we calculate the x displacement, what will that be? Into 1.7, right? What is v? 25. What is cos 60? 1 by 2. So this is equal to 21.25 meters. Substitute for v this much, Cos 60 we know is 1.1 by 2, 0.5, and 1.7 is how much? The time. So we are calculating for the particle 2 the horizontal displacement in time equal to 1.7 seconds. We know that the horizontal component of the velocity is constant, so we just have to multiply the horizontal component with the time, which will give us the horizontal component of the acceleration. Now let's come to the vertical component of the displacement, Sy. Again, this equation we have to use V sine 60 into 1.7 plus half minus 9.8 into 1.7 square, right? What is V? V is 25 meters per second square. Sine 60, because this velocity has a horizontal component of V cos 60, which we've taken here when we were calculating the horizontal component, and that velocity vector has a vertical component of V sine 60. So when we are calculating the vertical displacement, V sine 60 will be the initial vertical velocity, and that we'll have to use in this equation. As far as the time is concerned, time will remain the same, 1.7 plus half 80 square. A is equal to minus g because it's acting in the downward direction, and time is again 1.7 seconds. So this value is the vertical component of the displacement of the particle 2 in 1.7 seconds. Calculate this. How much is this? meters. Right? Now for particle 1 we have calculated the vertical displacement of particle 2. We have calculated the horizontal displacement and the vertical displacement. We know that the particle 1 will only have vertical displacement and no horizontal displacement because it is thrown vertically upwards. So its velocity does not have any horizontal component, so it does not move at all in the horizontal direction. Right? So now what is the distance between particle 1 and particle 2? Difference in x, square that, difference in y, square of that, and then under root of the whole thing. Right? So this distance that we want will be equal to difference in x. Difference in x will be this much. Why? Because particle 2 only is the particle which has only a horizontal displacement. Particle 1 does not have a horizontal displacement. 21.25 square plus difference in the vertical displacement, 28.339 minus 24.639 minus 24.639 under root of this. Right? So this will be the distance between these two particles. And the basic reason what we have, in fact the logic that we've used out here is that, say you have an xy plane like this, okay, this is y and this is x. So there are two particles, 1 and 2. Particle 1 has a certain x coordinate, say x naught, and y coordinate, say y naught. Particle 2 has a certain x coordinate, say x1, and y coordinate, say y1. So what is the distance between particle 1 and particle 2? Square root of difference in x coordinates plus square of difference in x coordinates plus square of difference in y coordinates. So what is the difference in x coordinates? x1 minus x0. Square of this plus what is the difference in y coordinates? y1 minus y0. Square of this and then under root of the whole thing. Why? Because this is basically, if you can consider this is a right angle triangle, Pythagoras theorem, you can apply it to this. This is x1 minus x0. This is y1 minus y0. So naturally this distance is what is the distance that you are looking out for or are trying to calculate. This, you know, from Pythagoras theorem will be equal to under root of square of this plus square of this. So this is the way to calculate distance between two particles with respective x and y coordinates.